After adding devices and objects in data acquisition, the next step is data forwarding. EG71 can forward data to HTTP/MQTT servers, or operate as a BACnet/Modbus server itself, automatically converting protocols and sending data to your chosen platform. I will using some free tool to realize the data forwarding for demo. First up is HTTP forwarding. Click Add and select HTTP. Start with filling in name and description. You may optionally enable metadata for LoRa and other protocol devices. This adds lightweight context to your messages without requiring predefined objects. Next, configure the HTTP server details and specify URLs for different data types, such as uplink, acknowledgement, error, online, and offline events. Once the server is added, select the forwarding objects from the existing devices and objects created during data acquisition. To verify the setup, check the data pushed from the gateway. HTTP is ideal when you need to actively push data to a cloud API or a third-party web server. Next is MQTT forwarding. MQTT supports publish/subscribe messaging. Broker address. Enter the address of your target broker. The port depends on whether TLS is enabled, typically 1883 for plain, 8883 for TLS. Client ID is a unique identifier for the gateway on the broker. You can customize it. If your broker requires authentication, enable user credentials and enter the username and password. Or enable TLS to select certificate. We don't need here. For the data format, you've got two choices: combined reporting, which bundles all object data into one message, or per object reporting, which sends each object separately. And just like with HTTP, you can enable metadata for extra context. MQTT supports 9 different topics: uplink, downlink, multicast downlink, online, offline, ACK, error, request and response. Test uplink as an example. EG71 support will configuration to notify other devices that the gateway has gone offline as needed. Apply and move to pick the one of forwarding objects from the existed devcs and objects added on data acquisition. To verify, use MQTTX to subscribe to the same topic and view the incoming data. MQTT forwarding is ideal for bidirectional communication. To run as a Modbus server, configure the connection method, either Modbus TCP or Modbus RTU over TCP. Pick your network interface, and set the port, server ID, and description. Enable global objects. This automatically attaches any fixed or shared objects to every forwarding object. Apply to go to the object list and add the data objects you want to expose. To verify, use Modbus poll to connect to the gateway and read the registers. Open the object list again and select one object to get register type, register address, and data format. These are needed when the client reads the registers. And verify with Modbus poll, entering the matching parameters, and you'll get the present value. Modbus forwarding is ideal for third-party clients such as SCADA system to read data. Finally, let's configure the BACnet server. Use the standard UDP port 47808. Select the network interface, for example ETH1, and set a unique device instance number along with a recognizable device name. You can also enable global objects. This automatically attaches common objects to every forwarding object, so you don't need to configure them repeatedly. If your BACnet clients are on a different subnet, you can enable BBMD and add the remote device information. After applying the settings, go to the object list and add the data objects you want to expose. If you need to adjust the global objects later, just go back to the previous page, make your changes, and apply again. Now here's a BACnet-specific feature, notification class objects. These allow you to send alerts to BACnet clients. Go to the NC Object tab, click Add, and define your alarm parameters. Then return to the device object list, click Edit on the target object, enable event detection, and link it to the notification class object. Once that's done, alerts will be sent to the BACnet client. To verify the setup, use YABE to scan or manually add the device. You'll see the object list populated. Check the present value in YABE. If the values match, the connection is working properly. Now let's test the notification. Go to Data Acquisition and send a downlink command. For example, set the valve opening to 20% to trigger an alert. Let's change the valve opening to 20% to trigger notification. Then go to Data Stream to check the downlink status. Since WT101 is a Class A device, you'll need to wait a moment for the downlink to complete. Keep refreshing the data stream until you see an ACK uplink from WT101 that confirms a successful downlink. Now go back to data forwarding and check the object's present value. It should now read 20. Open Yabe again and refresh the value. You'll see a notification icon appear on the valve opening object. That means the alarm has been successfully triggered. Click it to dismiss the alert. And that's BACnet forwarding, designed specifically for building automation system integration. So there you have it. With everything configured, your EG71 is now ready to collect data from devices across different protocols and forward it wherever you need it to go.